So just like we did with addition, we can formally define the multiplication operations on the complex numbers. So multiplication is also associative, i.e. it doesn't matter which order my multiplication is. It's commutative, so I can bunch them up in different ways. So for example, if I was to multiply Z1, 2, and 3 together here, it wouldn't matter if I multiplied the Z2 and Z3 together first, or if I multiplied the Z1 and Z2 together first. It's distributive, just like the real numbers. So if I multiply across an addition, we just add the multiplications. And it looks like I made a mistake there. That should be Z times 1 equals Z, because the definition of identity is that when we use this operation, nothing changes, okay? So Z times 1 is Z. And if there's an identity, that means that there's an inverse. If I multiply Z by 1 divided by Z, that's going to equal 1. And because there's an inverse, we also have Z to the minus 1, and that is 1 on Z. All right, let's get on to an example here, the final example of the lesson. So we have Z equals 2 minus 5i, and they want us to find Z to the minus 1. So we know from above that is just 1 on Z. And the numbers we have here are 2 minus 5i. So we use the complex conjugate of 2 minus 5i just by flipping the sign for the imaginary coefficient. And of course, we're still just multiplying by 1 there, nothing changes. So therefore, we've obviously got 2 plus 5i in the numerator, and the denominator should be the real coefficient squared plus the imaginary coefficient squared. And that's just 4 plus 25, so we now have 1 divided by 29 multiplied by that numerator. There's two little points I'd like to make here, and one is, generally speaking, Z to the minus 1 times Z should be equal to Z to the 0, and sure enough, that's the case. The other thing you should be able to see is that 1 on Z is going to equal 1 on Z times the conjugate on the conjugate. Our new denominator is the modulus of Z squared, and the numerator is the conjugate. And I'll leave it to you to check that multiplying Z by that will always equal 1. Now, I just want to say that the textbook has a good section on using the CAS for imaginary numbers or complex numbers. So please practice that, follow along what they have there. Also, question 9 follows on from that example we just did, and it has lots of properties that you need to test. So please get on with that. And following on from this lesson, our next lessons will be looking at complex numbers in a very different way. So yes, these are numbers, but they also have a geometric explanation. So make sure by the end of this lesson that you have completely mastered the algebraic techniques that we've learnt for addition and multiplication. All right, have a good day. Bye.